Can everyone hear me? Yeah? That's great. Okay, cool. Good morning, everyone. Welcome and I heard that. Good morning, everyone.
Good morning.
Woohoo! Thank you so much for being here. I'm super excited to be here. It's actually my first Microsoft build. And so far, it's been an incredible experience. How many people here have been to the Puppies Lounge? Not enough. Everyone should go there, pet some puppies or some ponies and some bunnies. So you should definitely go check it out. Allison has made a huge effort to make that happen, and I think everyone should try to enjoy it as much as possible. Okay, I want you all to take a second and think about Twitter. And think about Twitter in terms of scale. Twitter has 330 million users. It also has, every second, there's 6,000 tweets being created. Every minute, that's 350,000 tweets created. And that sums up to 200 billion tweets a year. And what this makes me think is, what if the founders of Twitter had just frozen thinking of these numbers? Like when you're building applications, one of the first things that you think of is how much you want to scale your application. So if you think back of the creators of Twitter, if they knew that these are the numbers that they're going to have to support, what if they wouldn't have created Twitter at all? How good would our lives have been? Well, basically, that's every startup idea that I've ever had. Yeah. A complete failure. But that's also the reason why I'm enjoying serverless, and I love serverless so much. It's because it allows me to think of the application that I want to build without thinking about the effort that I have to put in to scale our applications. And this is what we're going to talk about today. So today we're going to look into how we can take an application, an Express backend, and port it to a serverless backend by just changing a single line of code in our front end, and by not having to think about how much effort we have to put into scaling. And before we get started, I'd like to maybe make sure that everyone is familiar with what serverless is. How many of you have worked with serverless before? There's a few hands, which is great, but there's a few people that haven't worked with serverless. So then what serverless helps us do is basically write code without ever having to worry about infrastructure. So we don't have to worry about managing servers. We don't have to worry about managing infrastructure. We just have to write the code for our application and deploy that on our cloud provider. And there's three things that are super important about serverless. The first one is the fact that when we're writing serverless code, we are writing code that reacts to event. And by events, I mean things like whenever someone makes an HTTP request that our function is listening to, then our function is going to start running. Or whenever a file is being uploaded in a storage account, our function is going to start running. It's going to process that file, and maybe it's going to do something like saving that data into a database. Or a queue message has been posted somewhere, and then our code is going to run. So it's all event-based. The second thing that's super important about serverless is auto-scaling. We don't have to worry about that. Our cloud provider will make sure that we have enough instances running so that it supports all of the users using our product. And finally, one of the most important things is that we actually only pay for what we're using. So we're paying for the amount of memory and CPU cycles that are used whenever our code is running. And if nobody is using our application, that just means that our code is going to be stored somewhere in a storage account, and it's not going to run, and we're not going to pay for it. So I think that all these three characteristics of serverless makes serverless an amazing environment for startups. And what's even more amazing is Azure Functions. And that's what we're going to use today to have a look at building backend applications using serverless. My name is Simona Cotin, and I work as a cloud developer advocate with all these awesome people. that are here to support me. And that's some this is some art that has been created by our colleague Ashley McNamara, and I'm going to use some of this in a lot of my slides. So I want to introduce you to Bit, who is our friend. And there's a story behind that. The reason why Bit is a raccoon is because a raccoon goes everywhere. And that's exactly what our team is doing. Our team is going everywhere where you are, where developers are, and we want to get to know every one of you. Cool. And while preparing this talk, I was aiming to structure it so that I share most of my experience. And one of the ways I could structure it is like a full workflow. But then recently I met one of the co-creators of Egghead.io, and he was talking about the reasoning behind making short videos, like 2-minute videos, for all his courses. And one of them was because he wanted to solve a problem with each of those videos. So you could just watch 2 minutes, and then that means that you would definitely have a solution to a problem. So my approach to this talk was, what don't I know about serverless? And what do I want to solve? What type of problem do I want to solve? So that means that we're going to answer together a series of questions, like, how do I actually go about creating a project? Which are the tools that are available for me? And what do I want to choose based on what? How do I debug and run locally? We are developers, and that's actually very important. We want to be able to run all the code that we're writing on my machine, on our machine, before pushing it to the cloud. How do I install NPM packages? I know this is a very, it's a 101 question, but I think once you're moving to a new platform, things are just not as familiar. So you're asking all those questions that you already know the answer to. How do I connect to a MongoDB instance? Same thing. We know how to do that in an Express application. How do we do it in a serverless application? Because most of our applications are talking to a database. Where do I save my environment variables? I don't want to commit them to GitHub, right? I need a place to save them. How do I read data from, well, here I have Cosmos DB, but any other database as well. How do I do that? We're also going to learn how to configure REST-like URLs, because that's something that might be required for our APIs. And finally, how do we deploy to the cloud? Because we've written all this code that runs perfectly, and we can debug it in our local, but how do we actually push it to the cloud? Because that's the end goal. We want our users to use the application we've written. We want to hit those scaling issues. So what are we building? Pun intended. We are taking an existing Angular app that has been developed by John Papa and Burke, and we've been sharing it. And this is a page where we can manage puppies. I'm not sure if puppies and manage should be in the same sentence, but we're just going to go with it. So here we have, first we're going to create Beam, and Beam really wants to be Sarah's best friend. And then Sudo is just another puppy that actually wants to be Sarah's bestest friend. And then we also want to be able to update these entries, but also whenever one of them wants to take a break, maybe, we want to be able to delete items. The idea is to create a CRUD-like interface, or backend, right? Create, read, update, and delete operations. We want to support all of those. So how do we get started? How do we go about creating a new project? That's the first step, right? There are quite a few options there. Because I'm using a Mac, one of my criteria is to be able to use an environment that's cross-platform. So the first choice there is Visual Studio Code. But if you're using a Windows machine, then you should be fine using Visual Studio as well. It's very powerful. Another option to get started with serverless is just to go directly to the portal and create functions there, get started there. But obviously, you won't have as much powerful tools like being able to debug locally. You might have to just print things in the console, and that's not always great. And finally, if you like using a CLI, then the Azure Functions has CLI support as well. So we can use that to create new projects and to create new functions. But as I mentioned, I am a huge fan of Visual Studio Code, so I'm just going to use that. And the best thing that has ever happened to Azure Functions is the Azure Functions extension for VS Code. Can I hear a hey for that? Woo! I'm happy people agree. So with the Azure Functions extension, we can do things like create a new project. We can create new functions. We can publish them. We can manage them. We can edit settings. It's so powerful. It's just a line on the left side panel, but it's absolutely fantastic. And to install it, you have to go to the Visual Studio Marketplace, and you just download it and log in with your Azure account, and that's pretty much everything you have to do. And so from there, I'm just going to go back to my computer and start some live coding sessions. So I hope everyone's here with me. I've also recorded everything so that we make sure that if there's no internet or if there's any issue, I can still show you something. So I'll have to skip through some of these videos. OK, so I'm in my terminal right now, and I'm going to open code. Please let me know if it's hard to see in the back. Can everyone see the screen? Yeah? Perfect. OK, so as I mentioned, we have the Azure Functions extension. And in order to get started with a new project, we just need to click this folder button. And this will create a new function app for us. So I'm going to tell it to use the current folder. And you can choose different languages, like JavaScript, C#, and Java. They're all supported on a Mac in your local. And I'm going to choose JavaScript for this. And this is going to immediately generate a set of files for us. The first folder, VS Code, is a folder that will contain your VS Code configuration for debugging locally. The next file is just some common gitignore files. And then host.json, that's where you're going to configure your function globally. As well as with local.settings.json, we're going to be able to save some environment variables right there. The reason why we need a function app is because we want to be able to group multiple functions together. So we want to have a place where we put all our functions. So the next thing that we want to do is create a new function. And we're going to use the same folder. And there's different types of triggers that we have to choose from. So as I mentioned, these functions get triggered by events. And there's events like HTTP, blob, queue, and timer that will help us trigger a new function. So I'm going to choose, because we're building a REST API, I'm going to choose an HTTP trigger. And I'm going to name it get puppies, because we all love puppies. There's different authorization levels, and I'm sure that Brian, our security expert here, is going to be not very happy when I click anonymous. But for the sake of the demo, I'm going to use anonymous. And this is the boilerplate for, or this is just some helper code that has been generated for our function. And as you can see here, a new folder has been created for us, which is called get puppies, just like our function is called. And then inside, we have 3 files. Function.json is going to help us configure our function. Index.js is where all of our code is, or maybe we can add shared code in different folders, but this is where you get started from. And then sample.data is where you can add some data to test your function. So let's go ahead and have a look at this. Function.json is just a JSON file that has things like what are the bindings that we are going to use for this function, how is this function going to be invoked. And here we can see that it's going to be invoked through a HTTP trigger, which has an input direction, and it also creates an object called rec, which comes from request, and that's the object where we can get data from that relates to our request. And then we also configure the request, the response, which is our HTTP in-out direction. And in our index.js, this is a JavaScript function that receives 2 parameters. The first one is the context object, and we use the context object to communicate to our function runtime. And we can do things like log information, Or we can set the response for our function, but we can also take information like bindings. What kind of bindings are we using? As you can see in this function, the only thing that we're doing is just getting the query parameter or the body of the function. And then if that exists, we're going to reply back hello build. And then if that doesn't exist, we're just going to throw back an error. So who's excited to try this out? Yay! So get ready for this. This is again, we're going to see the power of Azure Functions. We can just go to our debugger icon right here, and we can click play. And this is going to start our function runtime. And once everything has started, we can see also that we get the URL for the function, which we can immediately call. So I'm going to copy this and go to Postman. Is this visible in the back? Yeah? Perfect. So I'm sending a request, and obviously it's going to tell me that I didn't pass a name. It expects a name from me. So I'm going to add that as part of my query parameters. And I'm going to say build, hello build, hello build. Well, you have just been very excited for the first part of running locally. The second important part is being able to debug locally. So I'm just going to go back to Visual Studio Code, and I'm going to add a breakpoint here. And I can just make a new request. And now I can step through my code and inspect variables. So I can just go and see what my request object has in it. I can also go ahead and maybe edit some of that data. So there's a lot of things that we can do with Visual Studio Code and the Azure Functions extension. But this is just a hello world function, right? So the next thing that we want to see is how to install. My Keynote has stopped working. How to install an NPM package. Does anyone here know how to install an NPM package? These are all the slides that I've created so that I have something backed up. So how do we install NPM packages? In a normal Express.js application, we just run npm init, or we create a new package.json, and then we go ahead and install dependencies. In our case, because we're going to create a REST API that's going to talk to MongoDB or to a Cosmos DB instance through the MongoDB API, I'm just going to go ahead and install a MongoDB package. And creating or installing NPM dependency in serverless is as simple as that. We have to create a package. But the powerful thing about installing NPM packages here is that we're going to be able to use all the Node.js node modules. We're going to be able to use them in all of our functions. So if you used Azure Functions before, you probably know that we had to just install NPM packages for each function. And that meant that there were some performance issues. It wasn't as great. Right now, it's the time to celebrate. We have node modules at the same level as the function app. So I'm going to go back to my IDE, and I'm going to create a new file. Package.json. Weirdly enough, English becomes a problem when you're on stage. And I've already created the file so that I don't have to type everything. I'm not a fast typer. So then I'm going to run npm install. I'm in the root of my function, and I'm going to run npm install. And this is going to create the node modules for us. So what's the next thing that we want to do? We want to go ahead and connect to our database, right? I already have an instance of Cosmos DB running, created. It's called Serverless Puppies. So I'm just going to go ahead and connect to that. And I'll go back to the get puppies function that I've created. Who here is familiar with VS Code snippets? A lot of people. Great. So I've created a snippet that will allow me to be very fast. Type very fast. Like 30 lines of code in 1 second. And we can have a look here. So the way we're connecting to our database, first we're importing the MongoDB package, and then we're defining this authentication object that has a user and a password, and we're using the MongoDB client to connect to our existing database. And I know that Brian is going to frown on this again. But let's just go with it, right? We have our function. We're connecting to the database. We're selecting the admin database. If everything goes well, we are selecting the puppies collection. And then we're just going to return all the puppies that we have in our database. So we've installed npm packages. We have written the code very fast. And then I'm also going to get you started on defining routes for our application. So function.json has this functionality where you can define for each HTTP trigger, you can define a route. So you can override the name. Remember the get puppies name that was generated for us. We can actually go ahead and use a different route that's much more REST-like. So I'm going to edit that here. And it's just route. And then it's going to be, the name of the path is going to be puppies. So then the method that we're going to listen to, we can filter by that. And we're going to listen to get methods. So if everything is correct, this means that this should be running. And I should be able to retrieve an empty list of puppies. Let's go ahead and test this. Okay, that's a 200 right there. Yay. Okay, so we have our empty list of puppies. And before we move on, as I mentioned, probably we don't want to go ahead and check this into GitHub, right? Because we are storing there our connection string to our database. Brian is having a heart attack right now. Why did you show that on screen? I'm going to refresh that, I promise. I'm going to regenerate that. But as I mentioned, we can actually go ahead and define environment variables in local.settings.json. So I'm going to go ahead and do that. Okay. This is it. It's a JSON file. So I can just say that I want to create a Cosmos DB user. And this is the user that we're going to use to connect to our database. And then I also know that I need a Cosmos DB password. And I'm going to go ahead and copy it from index.json. OK. Paste it. And then the next thing that we need is the Cosmos DB URL. Which I'm going to copy from index.js as well. Brand, soon this is going to be gone. You're going to be happy. OK, so now this local.settings.json file, as you can see, it's not even green, which means that we're never going to check it in to GitHub unless we really want to. So this has been added to my gitignore file so that it's not going to be checked into GitHub. OK, and how do we access these variables in the index.js file? Well, we go back to our object here, and we use the process object environment, and then we just use the same name that we've defined earlier. Cosmos DB user. And then here we're going to define the Cosmos DB password. And finally, we need the URL. OK. And I'm going to run this again to make sure that everything's still working, because this is we still have a few steps to cover. I want to make sure that each one of them works. So we're good. We have just moved our secrets from a file that gets, yeah? We're not good. But it was green. OK. Cosmos DB. Which values? It does? Oh, yeah. I've stored them outside values. Perfect. Thank you. That's teamwork, right? Uh-oh. We have to restart this. OK. OK, 200. Thank you very much. OK, so the next step would be to create a new endpoint for creating puppies and then updating puppies and deleting puppies. We can do that right now. I've prepared my snippets as well. So then let's create a new function in the same folder. Again, an HTTP trigger, create puppy, anonymous. And then here, I'm just going to reuse the snippets that I've created. I'm already using the settings that we've defined earlier. So that's another great cool feature of local settings.json. You're just reusing, for all of your functions, you're reusing the ones that you've defined in your function app. So the only thing that we have left to do here is just define a new route, because we want our create function to have a new route. And this is going to be puppy. And the method that we want to listen to is a post method. And I can go ahead and run this. And I've created a new Postman entry here, which will create puppies for us. And now, if I go back to get puppies, so this has returned 200 here. And if I go back to get puppies, this is going to return the first puppy. Yay! I think that just seeing the create puppy and the get puppies endpoints, this has been very powerful. So I'm going to go back to my presentation and walk through some of the remaining items or remaining questions that we had. So we've seen how we create a package.json file. And then we've seen how we can connect to a MongoDB database. So we're just using the MongoDB package, and then we're storing our secrets. That's the Brian police. That was for you, Brian. Wait, it's here. OK, and now I've moved the settings into our local.settings.json file. And we're using those variables. So then the next thing that we want to do, with Cosmos DB, as I mentioned, there is this thing called bindings. And bindings are objects that allow us to communicate to different data sources. And what I mean by data sources is things like Cosmos DB or even a queue or a file. And there's different, we can both read from a binding and also write to a binding. So there's an input binding and an output binding. And the typical types of bindings are a blob one, a Cosmos DB, a queue binding, but also there's a lot other types of bindings. Like we could use event grid to read events from that. But the one that I'm super interested in is the Cosmos DB binding. And right now, to use the Cosmos DB binding in your local, we have to install a separate extension. So some of them are supported out of the box, but this one, Cosmos DB, we have to extend the runtime so that it supports Cosmos DB. And then to use our binding, we have to define in function.json, we have to define it. And the type has to be Cosmos DB, and also we have to specify to which database we want to connect to, as well as which is the collection name that we want to access, the query that we want to use to retrieve all the data. We have to give it a connection string because we want to make sure that we can connect to that database. And once we have this set up, get ready to have your minds blown. This is it. This is all we have to use to get all the data from a collection. So we have to access the bindings object, and we use the all puppies name of the variable that we've defined in local setting, in functions.json. I think this is really powerful. So we can use this even for things like when we want to read from the database and update some other things. This is powerful. This is great. How do we do REST URLs? Well, we've already seen a part of it where we've defined the routes inside the function.json file. These are the URLs that we want to make sure that we have covered. And this is where we define them. We just use routes to define different routes. And one thing that's important here is the fact that we can even give variables in our URL, like ID in this case. And this will be passed to our request object. And another powerful feature of serverless on Azure is that we can use proxies to connect different function apps within the same domain. So imagine you have a function app that supports all these CRUD operations for puppies, but you also build another application that will allow you to verify if the description that I added is okay, like do content moderation on text. And we want to call a cognitive services API, so that becomes a lot of logic that we might want to separate into a different function app. But that's still part of our application, right? And we want to deliver it under the same domain. With proxies, we can do that. And we can define proxies either in the portal or using, in our local, using proxies.json file, which is in the root of our function app. And this is a JSON object where we just have to define things like which is the route that we want to match, as well as which are the methods that we listen to, and what backend URI we want to call. So this is it's not a lot of lines of code. It's not a huge number of lines of code, and it allows us to build powerful things. This is another thing that I've struggled with. How do I do cores? Because we're using an Angular application that's going to call serverless endpoints, it's going to call an outside URL. So we want to make sure that we define cores for this. And the way we do that is go back to our local.settings.json file. And this will allow us to just add cores, and then we can define rules which are stricter than just everything. This will enable us to run our applications locally. And then in the portal, we have to go to the platform and define their cores rules. How do we deploy? We've built our application. We have all of our endpoints. We now want to push it to the cloud. One option is using the Azure Functions extension. We have here a button that will just tell us that we can publish our application, and we have to define things like to which function app do you want to deploy, what's the subscription that you want to use, and then what the extension will do is basically zip up your code together with the Node modules and just push them to the cloud. Another option that we have, once we have tested our code and everything looks good, we can also use a very common pattern where we're pushing our code to GitHub, and then for each commit that happens, there's a webhook that will let functions know that we need to deploy a new version, and that's going to happen. But for local development, publishing your app using the extension is the best option. Okay. Demo time. So I want to show you how we can connect our Angular app to the two functions that we've created. So read the list of puppies and maybe create a new puppy. I have the Angular app running in my local. And you can see here that I'm connecting to so we have a client and a server. This is where our Express code is. This is where we connect to our database, but we just want to not use the server at all. So we want to go to our UI and immediately make a request to our function. And we do that in the puppy service.ts. We have this API URL, which is just calling the API from Express, but we're going to replace that with our function URL. So I'm going to copy this and just delete this last part. OK. And this means that our getPuppies function here will be able to retrieve data from the database from Cosmos DB through the function. Let's make sure that our functions are still running. OK, perfect. So now, if I go to the browser, the application is still loading. But one thing that I didn't do, can anyone guess? Course. Perfect. So I have to go back to the function. And in local.settings, I just have to, I have to add host and just course. We need to restart. And this should enable us to connect to the serverless endpoints. So let's do this again. And here we are, the bestest puppy. And the last thing that I want to show you is the fact that you can go ahead and monitor your functions. So basically, one of the first arguments for serverless is the fact that you can scale your applications. And we want to be able to load test our functions to make sure that that's actually true. And Azure Functions has support, or App Insights and Azure Functions are integrated very well. So we can go ahead to App Insights, and while making requests to our function, we can see real-time our requests coming in and the number of servers being used while we're doing that. And I'm going to use Artillery. Is anyone familiar with Artillery? It's an NPM package that can be used to run load testing. So if you want to do that not only for serverless, but even for other for your websites, for other tasks, you can easily use it to make requests. So I'm going to just copy this and OK, and just make a request to one of the functions that I've already deployed previously. Let's say this one. So to run artillery tests, we need to, here we're telling that we want to add 10 users that make 20 requests, no, 20, yeah, to this URL. So I'm going to enter this and then go back to our live metric stream, and hopefully this will start. So So we can see that we have one server online here, and some requests are coming in. And the number of servers is updating. So now we have 4 servers online. And we can also monitor things like how long does the request take. We can see outliers, like some requests have taken a few milliseconds, but then we also have a few requests that have taken longer, and we can see that on the screen. The sample telemetry panel there, it will also allow us to see some of the errors that we might have in our functions. So this is a very powerful window. And this is it. We've seen today how to create a project with VS Code and Azure Functions. We've also seen how to debug functions locally. How to install NPM packages, we know this already. How to connect to MongoDB, nothing new there. How to save my environment variables, we have to use local.settings.json for that. How do we read data from Cosmos DB? Using bindings and functions extensions. How do we configure REST URLs? Well, we make sure that we use proxies.json, but also we can use the function.json file. And finally, how do we deploy to the cloud? Again, we make use of VS Code, but also we can use GitHub and other CI tools. This is just covering, like scratching the surface. There are so many other things that you can do with serverless. So if you want to learn more about serverless, make sure to check out some of these sessions about serverless, or how to use Node on Azure, or how to use cognitive services on Azure. And if you want to read more, here's a list of resources about Azure Functions and VS Code extensions and Azure Cosmos DB. Thank you very much. Enjoy build.